I'm sure you may be puzzled on how pilots and air traffic controllers communicate and share data to ensure flight safety. It's a question that might have crossed your mind as you sit comfortably in your seat, cruising at 35,000 feet. Communication, you see, is the lifeblood of aviation. It's the invisible thread that connects every moving part, ensuring that your flight is not just smooth, but safe. Now imagine a world where this communication is digitized, made instant, and error-free. This is where the controller-pilot data link communication system, or CPDLC for short, comes into play. It's a method of communication that's revolutionizing the aviation industry, making air travel safer and more efficient. It's like sending a text message from the cockpit to air traffic control, cutting out the possibility of misunderstood radio transmissions and reducing the chance of human error. Well, let's delve into the fascinating world of aviation communication and see how these very important professionals ensure flight safety both for passengers and ground crew members. Now, you might be wondering, what exactly is this CPDLC system we're talking about? Well, let's get to that. CPDLC stands for Controller Pilot Data Link Communications. It's a system that allows pilots and air traffic controllers to communicate with each other through data links rather than voice communication. Think of it as texting, but for aircraft. This system is primarily used for non-urgent communication. It's not intended to replace voice communication entirely, but rather to supplement it. So if there's an immediate danger or an emergency, voice communication is still the go-to method. Now, how does this system work? Imagine you're a pilot flying over the Atlantic. You receive a message from air traffic control, but instead of hearing it over your headset, it pops up on your flight deck display. You read the message, confirm that you understand it, and respond accordingly. All of this is done through the CPDLC system. One major advantage of the CPDLC system is that it reduces the chances of miscommunication. You see, issues like heavy accents, background noise, or poor radio quality can make voice communication difficult. But with CPDLC, the messages are clear, concise, and there's a record of every communication. Additionally, CPDLC improves efficiency. Controllers can send the same message to multiple aircraft at the same time. This is particularly useful in busy airspaces, where air traffic controllers have to manage many aircraft simultaneously. Another benefit is the reduction of radio frequency congestion. With less voice communication, there's more space on the airwaves for urgent messages and emergency communications. There are also some safety benefits. For instance, the CPDLC system can automatically alert pilots if they're about to enter a restricted airspace, thereby helping to avoid potential conflicts or violations. So in essence, the CPDLC system is the unsung hero of aviation communication. It's revolutionizing the way pilots and air traffic controllers communicate, making air travel safer and more efficient for everyone involved. Safety is paramount in aviation, and the CPDLC system plays a critical role in ensuring this. Imagine a bustling highway in the sky where planes are the cars and air traffic controllers are the traffic cops. It's a world where split-second decisions can mean the difference between a safe journey and a catastrophic accident. In this high-stakes environment, efficient, reliable communication is crucial. Here's where the Controller-Pilot Data Link Communications, or CPDLC, comes in. CPDLC is like a virtual bridge connecting pilots and air traffic controllers. It's an advanced system enabling text-based communication, bypassing the traditional voice-based method. This might seem like a small change, but its implications for safety are enormous. Consider a scenario where a pilot needs to change altitude due to unexpected turbulence. In the past, this would involve a series of voice exchanges, with potential for miscommunication due to poor radio quality or accent differences. But with CPDLC, the pilot can send a clear, concise message directly to the traffic controller, reducing the risk of misunderstanding. CPDLC also allows for pre-composed, standardized messages to be sent. This means that even in high-stress situations, the risk of errors due to hastily composed messages is significantly reduced. Moreover, CPDLC enhances situational awareness. Controllers can send information about weather conditions, turbulence, or traffic directly to the cockpit. This allows pilots to make informed decisions, leading to safer flights. And let's not forget, CPDLC reduces voice congestion on radio frequencies. This means that in emergency situations, valuable airtime won't be taken up by routine communications, making the skies a safer place for everyone. But perhaps the greatest safety benefit of CPDLC is the reduced workload for both pilots and controllers. By eliminating the need for repeated voice exchanges, they can focus more on their primary responsibilities, keeping the aircraft safe and ensuring a smooth flight. Indeed, without the CPDLC system, our skies would be far less safe. So we've learned quite a bit about the CPDLC system, haven't we? Let's take a moment to reflect on what we've covered. We started our journey by delving into the intricate world of air communication, understanding its complexities and how it forms the backbone of aviation safety. It's a fascinating world, isn't it? A world where every message, every instruction, every single word matters in ensuring the safe passage of aircrafts through the skies. From there, we moved on to the CPDLC system, or the Controller Pilot Data Link Communication System. We saw how this digital communication system has revolutionized the way air traffic controllers and pilots communicate. Gone are the days of solely relying on voice communication. Now, with the CPDLC, important messages and instructions can be exchanged in written form, reducing the likelihood of misunderstandings that could potentially lead to dangerous situations. We also discussed how the CPDLC system plays a pivotal role in aviation safety. By providing a clear, concise, and efficient means of communication, the CPDLC system not only enhances the accuracy of message exchange, but also reduces the workload for both pilots and air traffic controllers. And less workload means more focus on the task at hand, which in this case is ensuring the safety of everyone on board. The CPDLC system isn't just a tool. It's a safety net that stretches across the globe, connecting thousands of flights every day. It's an integral part of the aviation industry, and its importance cannot be overstated. It's the silent hero that plays a crucial role in every flight you take. Pilots communicate with air traffic controllers, ATCs, using a standardized system of language and equipment to ensure safe and efficient flight operations. Here's an overview: communication methods. 1. Radio communication. Pilots use two-way radios to transmit voice messages to ATCs. The most common frequencies are VHF, very high frequency, 118.0, 135.975 MHz, UHF, ultra-high frequency, 225, 399.95 MHz 1. Data communication. Some aircraft are equipped with data link systems such as ACARS, Aircraft Communications Addressing and Reporting System, CPDLC, Controller Pilot Data Link, Communications Fans, Future Air Navigation System 1. Intercom. In the cockpit, pilots use an intercom system to communicate with each other. Standard phrases and terminology. 1. Call signs. Pilots identify their aircraft using call signs. 2. Clearance. ATCs issue clearances for takeoff, landing, or flight path changes. 3. Instructions. ATCs provide instructions such as altitude assignments or vectors. 4. Acknowledgements. Pilots acknowledge instructions with phrases like Roger or Wilco. Communication protocols. 1. Initial contact. Pilots establish contact with ATC using standard phrases. For example, good morning, this is Delta 123. 2. Position reports. Pilots provide regular position updates. 3. Clearance requests. Pilots request clearances for takeoff, landing, or flight path changes. 4. Readback. Pilots repeat instructions to ensure understanding. Equipment and tools. 1. Radios, VHF, UHF, radios with multiple frequencies. 2. Transponders. Respond to ATC radar interrogations with aircraft identification and altitude. 3. GPS, global positioning system for navigation. 4. Electronic flight bags, digital tools for navigation, weather updates and communication. Safety features. 1. ATC radar tracks aircraft positions and altitudes. 2. Collision avoidance systems warns pilots of nearby aircraft. 3. Weather radar provides weather information. 4. Emergency procedures establish protocols for emergency situations. International considerations. 1. Language. English is the standard language for international aviation communication. 2. Phraseology. Standardized phrases and terminology are used worldwide. And lastly, regulations. Compliance with International Civil Aviation Organization, ICO, regulations, and other administrative and safety guidelines.